now we can put those concepts together and we can hit a first derivative test. Okay? All right. Let's erase this. I hate to do this to you, but I want to show you a picture before I move on to that first derivative test. So I'm going to go 1, 2, 3, 4, 5, 6, 7 on the x-axis, 7, 0. I'm going to come down here to 1, 2, 3, 4, 1, 2, 3, so 4, negative 3. And then over here at 1, 0. Over here at negative 1, comma 2. A little bit further, 1, 2, 3, negative 3, comma 0. And this is my x-axis again. Okay. So I'm going to draw this picture in such a way that negative 1, 2 is my relative max right there. I'm going to come back down. I'm going to come through 4, 3. I want to make this nice. I'm going to put a little horizontal tangent line right there, so you should know that I'm getting ready to do a little whoop whoop thing. Okay? So we're going to scoop up and we're going to scoop down, and we're going to merge it. This will be my low point, my relative min. Okay, so you have enough information on this board. We're going to call this the function f. I want to know, where is f increasing? And where is f decreasing? All right, so the increasing. Where is the function f increasing? I'm going to trace the function everywhere that I think from left to right the function is going up. There we go. There's increasing up to that point. The function is not going up, the function's not going up, but from here it starts going up again, doesn't it? It hit a low and turned around and started going back up, and I don't know why I'm stopping, because you know what? That keeps going. Keeps going, keeps going, keeps going, and I should really bold my arrows as well, because it keeps going, and those arrows represent some kind of infinity somewhere. Okay, so those are the intervals on my graph where the function is increasing. Now I'm going to shade the corresponding x-axis for the same interval on the graph, but only on the x-axis am I going to do any shading. So this is definitely shaded here. I'm going to do this from left to right, not right to left. So doesn't this keep going down? And as it keeps going down, 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 aren't I spreading further and further and further to the left? I should be. So this axis gets shaded because all of these values are shaded below it. And it continues to get shaded all the way over to negative 1. But I don't want to include negative 1, because at negative 1, I don't feel as if I'm increasing or decreasing. I feel like that's my instantaneous point where I'm going to stop and turn around. So I'm not going to include this value. Nothing after it goes higher, so I can't include that value. You have to be able to be moving from left to right and continually getting higher. I'm not continually getting higher after the negative 1, 2, so I'm not going to include that. And I have all these, and then here at 4, I'm going to start shading here. I'm not going to continue that either. I'm not going to count that point, because not only do I have to continue getting higher, but I would have had to have been lower before that. So I'm not going to include this 4, even though there's a dot there. There's only a dot there because I'm labeling the point. But it's an open circle. Continue to shade, because something below this is shaded. Continue over, continue over. Now I can include that point, because something below it, something to the left of it is below it, and something to the right of it is above it. That's the idea. So we're going to continue going. And now I need to give you what's on my x-axis. This over here, I'm going to not label an x on this side. We're going to say this is negative infinity, and we're going to say that this is positive infinity. Still my x-axis, okay? So we're going to shade from negative infinity all the way to, this value is negative 1. And then we're going to start shading again at 4 all the way to positive infinity. So my function increases from negative infinity all the way to negative 1, and then starts increasing again at 4 all the way to positive infinity. The decreasing is the stuff that I didn't shade. So I'm not going to get a different color out or do anything different with it. I'm just going to give the interval for which we're not increasing, we're not constant, but we're definitely decreasing from this point all the way down to this point. So we're decreasing on the interval between negative 1 and 4. And this is it. Increasing and decreasing. All right. And while I'm at it, can't help myself. Do I have a relative max anywhere? And do I have a relative min anywhere? We've already talked about relative max and mins. Can you look at the picture and tell me a relative max? I'm hoping this negative 1, 2 is a relative max. Negative 1, I'm going to say at negative 1, 2. Okay? And we have a relative min where? At 4, negative 3. Now the reason I'm saying at is because I want you to recognize this as being an xy coordinate point. It kind of looks like the same things we had up here, not with infinities. Man, if I have infinities, I better know I'm playing intervals. But at that negative 1, 4 kind of looks like an xy point. It's not an xy point. It's an xx interval. Whereas these are xy points. So I put the at symbol there to tell you that that is the particular location as an xy point. All right. Can you tell me why you picked your max at negative 1, 2, other than the fact that it's relatively the highest point? What's happening as you approach negative 1, 2? The function is increasing, and after you leave negative 1, 2, the function is decreasing. That is why we have a max, because f itself switches from increasing to decreasing. Could we say that in terms of f prime instead of f? F prime switches from what? What would f prime be if f itself is increasing? If f is increasing, then f prime is positive. And if f is decreasing, then f prime is negative. I'm jumping ahead of the game, I just can't help myself. Why do we have a relative min here? We have a relative min at 4, negative 3, basically because it's the lowest point in a relative interval. However, what is the function doing as I'm getting closer and closer to this supposed relative min? The function is decreasing, and then the function is increasing. So we have a relative min because f is switching, or switches, from decreasing to increasing. Or, if I wanted, how could I say that in terms of f prime? F prime, which represents the slope of the function, or of each tangent line of the function, f prime switches from, let's think about it again, if the function is decreasing, means it's going down, so therefore its derivative is negative 2. And if the function itself is increasing, that means the function's going up, so its slope is positive. Okay, you don't know it yet. I just gave you your first derivative test.